Has everyone been to the keynote session this morning by Johan? Yes? You've all seen the great features. Okay, good. This morning, Johan and Nick, they showed a great a demo app of how you can help a maintenance engineer working on airplanes improve their job. I'm not going to talk about how their jobs can be improved today, right now. I want to show you a bit of what is happening under the hoods to make this all work. So have a quick look at how we did this on Amazon, what components on Amazon are involved, and how do we tie them up to the Mendix application. So this is the example that we started with this morning. Maintenance engineers can improve their life and do better jobs. We've seen many examples of how smart apps can actually bring a big impact on people, how they work and work smarter. Agriculture, in greenhouses, it's being used. The logistics of medicines, we heard that yesterday from Antil. Finding your maintenance cards on an airfield. So there's a couple of things that you need in place, components that you need to bring together in order to build these smart apps. As told you this morning by Johan, there's a piece of intelligence making information out of the data that you have in a way that you can even predict the future, in a sense. You need to know about who is using the app, where he is, what is the status of the things he's working with. And it needs to be proactive, so a user needs to know the right information at the right time so he can take the proper actions. And for these things, if you look at the technology, then you're talking about the devices, like the one that was taped on the airplane this morning on the model. It's a nice Arduino board that you can prototype hardware solutions with. But there's all sorts of industrial IoT already in place, has been for a long time. But all that data is becoming more and more available and easier to use in your own applications. Like the thing with the greenhouses, it's all built on Siemens equipment that has been around for quite a while. So it's not a new thing, that IoT, but it's becoming really available. So you need that. Then you need a place where you can collect all that data and manage your assets, your things, find out what the status is, change the status, so forth. You want to collect all that data because it can help you predict the future and improve the information that your users have. And that data can be used in machine learning, data science, deep learning. There's many names to it. We'll look at one example during the session. And I'm going to show you how you can enable this all on Amazon with their cloud, and how you can easily build a Mendix application on top of that. And the result will be a smart app built in Mendix, bringing a better experience to your users. So that's what it's all about for Mendix. It's bringing everything together that you already have in place and enabling people to quickly iterate and have new ideas of what you can achieve with that data, with those things, with the machine learning, and build better experiences. And if you look at it from a very abstract level at the architecture, there's a few components that are important. Like I said, assets, data, and algorithms. And what we are aiming for as Mendix is being independent of the platform that you choose. So we can run on Amazon and enable you to use everything that you have in Amazon, but we can also run on Pivotal or any other Cloud Foundry provider like Bluemix, IBM. And we also run on Azure, where you can take advantage of everything that you have in the Azure cloud. So it's really provider independent, but all of them have certain aspects that are important, like management for assets, management for big data, and management for machine learning and algorithms. So for now, our first aim was to look at Amazon, AWS, and enable that. But that's not the end point. Our aim is to provide you with the tools that you need to support all of these platforms and build your apps on that. So here's an example of a smart app. And then from the business perspective, there's a couple of questions that you can ask about this app, about the features and the functionality that your users may want to make it smarter than their previous apps. So what needs immediate attention? So it needs to know about your surroundings, about your context. What is my regular maintenance schedule? And I want it to be smart in the sense that I'm only going to put maintenance into things that need maintenance. So what is this component? It's very important that I have the proper work instructions per component for maintenance, and that I can also check that it was maintained in the past properly, and then I can document everything that I do to the component. And what are the historical sensor readings for this component? Is the heat of the temperature of the component, is it rising or is it okay? So if you break that down in the type of information that you need, it's about real-time information, what it is the status right now, and I want to change the status right now. It's historical data, collect everything and tell me what happened in the past, regular analytics. And there's a part of prediction. What is going to happen in the future? That's where the machine learning part comes into play. So just to break it down on what does it mean to get this pipeline of information running on Amazon, there's a number of components on Amazon that I want to highlight. Amazon has a lot of services. And you can do it in this way that I'm going to tell you about. There's other ways and other components that you can also use, and it really depends on the use case. For example, I'm going to talk about Redshift database as a data warehouse, big data store. We have other customers using DynamoDB, for example, as an alternative. It really depends on the use case. And we're going to tie those components of Amazon into your Mendix applications using the connectors that were just introduced. So I have a couple of them here. The AWS IoT Connector I'm going to talk about, the machine learning connector, the database connector, getting data out of Redshift, and the Watson services I'm actually not going to talk about. That's another session by Erno later today. So if you're interested in Watson, go there. Okay, so the connectors will enable you to use all these services that are in Amazon in your Mendix application. Let's start with the devices. So the airplane actually had a taped on Yun, which is really nice for prototyping, as I said. And there's other boards, like Intel has a board that enables you to do IoT things and prototype those solutions, and maybe even put it in production. This is a SODAC board by a Dutch company, Autonomo. They're building boards that have integrated LoRa, so for low energy wireless connections. Really useful. This is a 1M, 2M device that was used for the hackathon, so it was taped on doors of toilets and on the water cooker, and there was one taped in the fridge, so we can check whether the beers were cold. And this is actually an industrial IoT management device that you'll find in real life in production. That can be used, for example, in greenhouses to control all the lighting and the temperature and so forth. And these are getting internet enabled in the sense that you can, from here, directly send your information to Amazon, for example, using REST services and have it stored in DynamoDB. So it really doesn't matter what kind of device you use. In the end, it ends up somewhere in Amazon, and you can use it from a service. If you look at the connection, it uses MQTT, so it's a messaging protocol, and the device can send messages to Amazon, and Amazon will store it there and keep a status of the latest state. And it can also send messages back to the device, so we can turn on and off lights or open and close doors, for example. So let's look at the IoT connector. It's in the App Store. Currently, it's in beta. And we will provide a production version later this year. It will be open source, so anybody can contribute and expand the functionality of it. Currently, it does these things. So it enables you to find out what kind of things have I registered in Amazon. In Amazon, everything needs to be registered. And it will give you also a certificate, so you have a secure connection between the device and the storage in Amazon. So you can ask Amazon, what kind of things do I have? Give me some details about the thing. But you can also ask it, what is the current status of the thing? And can you please change the status? Ask it to change it. And you can do that in two ways. You have a REST endpoint, you ask for the shadow status, or you can send and receive messages. For example, for alerts, that's really useful. So here we use the thing connector, and it starts with the get list, and you get a full list of all the things, or you can filter on certain attribute values. This is a screenshot of Amazon things. So you see here 8 different IoT devices registered in Amazon, and all of these devices can have multiple sensors. But for now, we're just interested in knowing what devices are there. Maybe there's some attribute on it. For the hackathon, we used attributes like fridge or toilet, so you know where it's located. And from Mendix, you just use that connector, provided your AWS credentials. There's here something about attribute name, so you can filter what kind of things you are interested in. The result will be a JSON, and with our new excellent JSON mappings in Mendix 7, you will be easily able to map that onto your domain model. So with a few clicks, you have the data from Amazon into your domain model in Mendix, and you know about all the assets on Amazon. So now you know what you have. Now you need to know what the status is of those things. So the next part is what is the device status? When the device sends its update of its reported status, it is kept in a so-called shadow on Amazon. And it's the latest known state of the thing. And it has a REST endpoint. So we can just request information from the REST endpoint, and it will tell us whether the light is on and what the temperature is. You see here one example of a device. That's actually the Arduino device that we taped onto the airplane. And for that device, we can see that, for example, what the temperature is. And 21 degrees here. That's actually not true for downstairs. It was like 25 during the keynote. And during the hackathon, it even went up to 29 on Monday. So really hard work up there. There's other things like humidity and sound and light. And you can see when it was last updated, you have that information here as well. And as you can see, it has multiple ways of asking for that information. You have a REST API endpoint that you can ask for the status of the thing and also ask it to be changed, change the status. And you have an MQTT topic where you can receive messages about changing statuses of the thing. So that's the part where you, in Mendix, you can get to that data. It's an action. We could have also built this using our native REST API in the modeler, but this is just a little bit easier to use. So we've made it even more easier by packaging it in an action. So you have 2 actions, one to get the status of the shadow of the thing, and one to update it. So what does it look like? First, I need to know the endpoint of the thing. If you have different accounts or different zones, then they have different endpoints. You need to know the endpoint of the thing. Then you can go to the REST endpoint and ask for an update. So that's what we do here in the 2 actions. And then the next step is to get the JSON description of what the status of the thing is, and we map that onto your domain model in Mendix, so you can use it in your pages. Again, like any action, you have a parameter screen where you provide your credentials. In this case, I need to provide it with information about what thing do I want to be about informed. Here's an example of the data that is returned as a JSON, and then it's just a question of mapping it with the JSON mapper. So fairly straightforward. As you can see, whenever you paste in a snippet of JSON here, you can just take the example from Amazon, you paste it in here, and we'll show you the detected structure of the document. And you can update it here live, just add some attributes. You say, okay, I know that we'll also receive these attributes in the future, and then we'll update it here, and you'll be able to also map those attributes. So it's a really powerful way of mapping JSON onto your domain model. So, and then the last part is the interesting part here is, okay, now I need to know when something needs immediate attention because it's too hot, for example. On Amazon, you can define some rules, IoT rules, and it's like a query language, which you can see here. And so any message that is sent by a device ends up in its own topic, an MQTT topic, so a message queue topic. And you can say, oh, from these topics, I want to verify that for any message that arrives, certain aspects, so the temperature field, for example, is not over 25. And when it's over 25, I need to do something, so you can take immediate action. So these are wildcards, and here I can say, okay, for anything, it doesn't matter what the name is of the thing. If I receive a package of information, like check that the temperature is over 25, and when it's over 25, do something. And what can you do? You can do many things. We'll see more examples later on. One example here is the S3 action. It basically just saves the payload that you received on S3. And then you have it there, and you can always look it up. More interesting is you can republish it. So we have another topic here, MX Things Alerts. So this MQTT topic, and any message that contains a temperature over 25 degrees will be republished in this topic, and from the Mendix application will subscribe just to this topic, so that you receive messages for everything that's too hot. So how do you do that in the Mendix application? Again, you just have an action that says data subscribe to MQTT topic. You provide it your credentials. You also need to provide it a certificate and a client key, so the information that it knows who is connecting to IoT, and that you're allowed to get those information. You tell it what topic you want to subscribe to. And this morning you heard Johan talk about that you can specify Microflows. That's a Mendix 7 feature. Currently it's still a string. So that means that you can specify what Microflow needs to be executed when the message arrives. And then it will receive the payload, and then you can process that payload. For now, if you change the name of that Microflow, you will not get notified about the fact that you have to update this field also. So that's why one of the things that we are going to improve from Mendix 7. You will just have a list of values of Microflows, and you can select one. And if you change the name, we will automatically update it here as well. So this looks complex, but it is doing multiple things. This is the Microflow that's actually receiving the information about the thing when the temperature is over 25. And we save it, we do some mapping on JSON, and then we save it for the assets. And the interesting thing is here, we also create a push notification to your mobile device. So we also look up the maintenance engineer, and then send that information to the maintenance engineer. So on his mobile device, he receives a notification that something needs immediate attention. So that's the part. On Amazon, you can do lots more than just IoT, republishing it. So that you have Lambda, you can execute functionality. You can immediately send the data to machine learning and get some prediction on another value. You can save it to S3. And the next thing that I want to look at is Kinesis. Kinesis is like a buffer that receives a lot of information and then can store it in a database, for example, or like Redshift or DynamoDB, or do something else with it. Detect patterns in multiple messages. And I want to use that Kinesis Firehouse component to make sure that every message that is sent by the devices gets saved into Redshift. It may not seem like the obvious choice. Redshift is like a data warehouse service from Amazon. Many people will look for DynamoDB as a time series database. You just save the timestamp from the message and the whole message in a string or a JSON field. But it's a lot less flexible in querying terms, and you have to really think about, okay, how am I going to extract that information from DynamoDB? You have to create specific indexes for that. And Redshift just has a SQL interface. On the outside, it looks compatible to PostgreSQL. So you have all the power of SQL to get to your information if you store it there. So it's really flexible. That's why we chose it. As I said, this buffers all the messages. It receives like a stream of 5 minutes or a certain amount of messages saves it to S3, and then copies it into your database. So I have a rule, basically, that says from anything, if the topic starts with engine, so any device that has a name that starts with engine, and I'm going to republish it into Firehouse. And this is a configuration of Firehouse. So there's a couple of interesting things here. It says I'm going to receive a lot of messages, at the most 5 megabytes of messages or 300 seconds. And when I have 300 seconds of messages, I am going to copy it into Redshift. And that's about it. And then you have an automatically updated data warehouse with all the information from your things, all the status information from your things. And that looks like this. It's just an ordinary table. What is interesting is like the timestamp from when the device sent the message. We have a temperature, pressure, and other things. What device sent it. Within, for this particular use case, you heard Nick talk about the graph that puts it in 15-minute buckets. So we have a view in Redshift that does the aggregation, groups it by 15-minute buckets, and then calculates the average, max, and min temperature and pressure. So all that information is calculated in Redshift. So the question is, how do we get that information out of Redshift into your Mendix application? And that's where the database connector comes into play. So execute query to JSON, and from there, you just execute the query on Redshift. As I said, it's basically Redshift compatible, or Postgres compatible, so you can do any Postgres SQL, and it even has more like analytical functionality in there, user-defined functions. So it's really powerful what you can do with your data in Redshift. And from here, we can easily get it into Mendix. So you have like the action where you have to provide the credentials. Where's my database, a JDBC URL, and then there's one field that says SQL statement. For this, we will also introduce new parameter types that will make this SQL injection safe, for example, and also better performant. And the result of the query is a JSON field. So this is really meant for questions about a limited set of data that you need real time. So tell me the average temperature over the last 2 days or the last 3 days. So you don't want to copy over the entire Redshift database into Mendix. But you get the JSON, and then again you can use the JSON mapper to copy it into a Mendix domain model in an entity, and you have the data that you need for the chart that you saw in the maintenance demo application this morning. Okay, so we have real time. We know what assets we have. We know what the status is. We can influence that, and we know what the history of the status is. We can determine that using SQL. So now the last step is the machine learning. So 45 minutes is by far not long enough to explain anything about machine learning. Also, you need a much brighter person than I am. It's a very complicated field, and it's also there's lots of different terms that are being used: machine learning, data science, deep learning, so forth. And it goes from actually simple mathematics, statistical analysis, old-fashioned statistical analysis, all the way to neural networks. What you see on Amazon, what we're using, Amazon machine learning, basically is statistical analysis, and also a limited amount of analysis that they can do. They have classification, and they have linear regression. And linear regression enables you to say, okay, I have a certain values, and determine for me a function that based on these values, if I input them, some other value is calculated. So it's basic mathematics, which you had in university probably. But it can be useful if, for example, if you have like a number of sensor readings from your components, and say, okay, the temperature and the pressure and other attributes can tell me the remaining useful life cycle of a component. So it's going to last 100 more flights before it needs maintenance. So it can help you make a better maintenance app. So what do you need to do to use this on Amazon? This is, by the way, only one part of a machine learning solution that they have. They have also other things like Hadoop and Spark and lots of complex things. This is the easiest introduction to machine learning that you can use on Amazon. But you have to have a training set. And a training set basically says, for all these attributes, all these aspects of the sensor readings that I have, I know the outcome for the function. So if temperature is this and pressures, then there's 100 remaining useful life cycle flights for this component. And if you have lots of that data, then they can determine the function to predict that based on the attributes or the features. So you need a training set that you use to define the function. You need a testing set so that Amazon can determine whether the calculated function is actually correct. Then you need to define the model. To get the best model possible, you need to clean up your data. So normalize it, maybe reshuffle it so that the historical dependencies are gone. There's other things that you can do to improve the quality of the data so that you get a better machine learning model. You can evaluate it. It will show you the correctness of the model. And then you can define an endpoint, which is basically a REST endpoint, which you send new data, and it will tell you what is the calculated value using the model. And again, it's just statistical analysis in this case, mathematics. Here's an example. The training data in our example was in Redshift. And you see that this is taken from a set of NASA data from space shuttles. And it's also being used by Microsoft in some examples from machine learning. And it actually has like more than 20 features that they calculate. But if you look at it and you bring it down, you can bring it down to 3 components here that will have the most influence on the remaining useful life cycles. So this is basically the value that we want to calculate, we want to have predicted based on the input here. So we'll first take the training set and use that to create a model. So in Amazon machine learning, you have to define these data sets. As you can see here, a data set you can take straight out of Redshift. This takes the data out of Redshift. And you see your target field here, that's the RUL, the remaining useful life cycles. And that's what we want to determine. And you also see that it's a numeric field. And this has a big impact on the type of model you can define or it will create for you. So we have now 2 sets, one for testing, one for training. We can create a model. Again, it says here it's the remaining useful life cycles. It's numeric. Here's where you tweak the way it calculates the best possible formula. So I tell it to take 100 passes to get to the local optimum of the function. So it takes a number of steps to determine what's the best model possible. As I said, you can shuffle the data around to remove the historical dependencies between the records. And then it determines the model, or the machine learning model, and it will tell you how correct it is. Or it will compare, it will take the test set, see what the outcome is of the model, and then we'll show you how much it differs from the optimal result. So you can see here there's some values the most values are 20 off, some values are even 40 off. So if the RUL is 91, it could be between, let's say, 50 less and 50 more. So it's not really exact, but it gives you a hint of does it need maintenance right now, or can it wait for maintenance? Here's where we create the endpoint. And again, it's just a REST service now that you can call from an action. Okay, let's test it. Let's input this record with ID 5, these values. They have a test form where you can enter the data. And then if you try it, you'll see that the outcome will be, in this case, 101. So it's 10 off. So that's what the machine learning can do for you. This is a linear regression. It's also very useful if you have like binary classification. Is it true or false? Is it broken or not broken based on some input. Now what you can do in Mendix is basically the same thing. You can create a new record set of input values, then call the machine learning model in Amazon, and it will tell you the remaining useful life cycles. So this is what you just saw. You have to send Amazon a list of key values of the input attributes, the parameters, and the value, and it will return that calculated value. So that's what we build up here first. Then we call the endpoint in Amazon, and you can use the outcome. So just to make this a little bit more techier, we'll do a live demo. So I already entered all the fields here that you just saw here. So we have 642, 1589, and 1419. Oh, I think you're not seeing what I'm seeing.
Do we like it?
Okay, so yeah. So here was the model in Mendix itself. Here's the application actually running. So I can predict the rule, and then you always see that you get an error. And I know what it's configured for the main stage wireless. So let's see if I have nah. So you guys have to trust me on this one then. Yep, and we're back. So basically, you can call that model that you defined in Amazon Machine Learning, provide it with new data that you have in your Mendix application, and it will provide you with a prediction of what the other value will be. And as I said, this is one type of machine learning. There's tons of other ways of doing machine learning that may be better suited for your situation. We have the option of using IBM Watson, which has image recognition. You can have dialogues with your spoken dialogues, other things. I can tell you everything about that in a later session. But what we aim to do here is that, as you can see, the whole Amazon piece is pretty complex. It's very techy, very low level. But once you have that in place, it's now very easy to create new applications and IDs on top of the assets that you have in Amazon. And that's what we try to enable you to have, like the citizen developer with the web modeler, just create a new IDs on top of what you have in Amazon using these connectors that we are making available in the App Store for Mendix 7. I think we have some minutes for questions. Anybody?
Yeah. Is it currently possible to also add feedback loop to the Amazon machine learning? So the method predicts like 71% predictability, but you can tell it, yeah, that's right, or no, this is way off. So feeding the training set,
No, then you have to basically retrain the whole model again. You can extend the training set and then recreate the model, and then you have a more improved model, but
it's more like a nightly thing.
yeah. Sorry?
I said the cloud services are awesome, but
Yeah.
how do you cost this? So if you look at using the cloud services, I think the question is...
On the Amazon, you mean?
Yeah.
How do you cost it?
If you wire up all these services, how do you actually calculate the cost?
Yeah, that's an interesting question. Basically, you have to pay for usage, and it's really depending on the component and how many messages you send, and how, well, Redshift is the size of the data warehouse that you pre-configure. So that's pretty much something that you can estimate. But the other parts are based on the usage. So that's a bit harder to estimate.
You actually need a tool.
Yeah, I think there are like spreadsheets out there that you can enter some values in, and then they will give you a guesstimate. Yeah.
Is it not limited to just the IBM Internet of Things, and do you have any plan of to the other services as well if we provide them?
Yeah.
I mean, if some other services.
Currently, what we have is what you saw on the screen.
Yeah.
We do aim to provide connectors to all the other platforms, but as also said this morning by Johan, it's all open source.
Yeah.
Anybody can use the connector kit, so if you want to make an action that ties into some other service, you're very welcome.
Ah, yeah. There's a session on that as well.
Yeah.
Thank you.
Okay? Thank you.